Hello student, in this session we will discuss about master method for the solving of the recurrence relation. And for the application of master method, every recurrence relation should be in the form of Tn is equal to a Tn by b plus Fn, and where value of the a must be greater than or equal to 1 and value of b must be strictly greater than 1 are constant, and Fn is Fn should be asymptotically positive function. Okay, now if your recurrence relation is in this form, then you can apply the master method. And for the application of master method, there are three methods, three cases: first case, second case, and third case. As per the first case, if the value of Fn is big O n to the power log a at base b minus epsilon for some constant epsilon greater than 0, then Tn is equal to theta n to the power log a at base b. Now we have to find n to the power log a at base b. From the recurrence relation, you can find out value of a, value of b, and then you have to calculate the n to the power log a at base b. Okay, after the finding of the value, you have to compare Fn and this quantity. Now in this case, Fn is big O n to the power log at base b minus epsilon. This simply denotes that value of Fn is smaller than n to the power log at base b, and this should be in polynomial form. Okay, that means smaller or greater should be in terms of polynomial. Now we'll discuss some example after discussing these cases. Now come to the second case. As per the second case, if value of Fn is theta n to the power log at base b, then solution would be Tn is equal to theta n to the power log at base b into log n at base 2. Okay, so it says that the value of Fn and n to the power log at base b both belong to the same polynomial degree, that means both are polynomially equal, then second case is applicable, and the solution is very simple. You can find out in a single line, and that would be n to the power log at base b into log n. That means we have to multiply the log n and the value of n to the power log at base b. Now come to the third case. Third case says if Fn is equal to big omega n to the power log at base b f plus epsilon, that means value of Fn is greater than n to the power log at base b, okay, for some positive constant epsilon greater than 0, and if this condition is true, then if AFN by b is less than or equal to CFN. Okay, this additional condition for the case 3, what is it? Is AFN n by b less than or equal to CFN for some constant with c which is less than 1, and for all sufficiently large value of n, then solution would be Tn is equal to theta Fn. That means for the third condition, the value of Fn should be greater than n to the power log at base b, and we have to check this condition also. AFN by b is less than or equal to CFN. This condition is called the regularity condition. Now if both these two conditions are true, then the solution would be Tn is equal to theta Fn. Now student, let's discuss some examples. Our first example is Tn is equal to 9Tn by 3 plus n. Now if I compare this recurrence relation with this generic form of recurrence relation, the value of a would be 9 and value of b would be 3 and value of Fn would be n. Okay, so value of a is 9, value of b is 3, and value of Fn is n. Now for the applicability of cases, first of all we have to calculate one value, that is n to the power log a at base b, and in our case for this example it would be n to the power log a, what is the value, 9, n to the power log 9 at base 3, and is nothing but n square. Now after finding the value of n to the power log at base b, you have to compare it with your this fn. Now if I compare fn and n, and value of n is n to the power log a at base b, it is smaller in our case because it is n square, it is n. Okay, so it is clearly visible a value of n is always less than n square. So in our first case is applicable. Okay, so if I want to apply first case, I have to find out the value of epsilon. What is the value of epsilon in our case? Now if I reduce 1 from this, then they will become the same order. Okay, so in other word we can say the value of epsilon is 1 in our case. Okay, and I can write like this. Now n is equal to big O n to the power square minus 1. Okay, so from here value of epsilon is 1, and what was the another constraint on epsilon? It must be greater than 0. So in our case it is 1 which is greater than 0. That means first case is applicable. If first case is applicable, then we can write the solution directly, and what would be Tn is equal to theta n to the power log at base b. And what is the value of n to the power log at base b? It is n square. So this is the solution. Now discuss one more example for master method. Tn is equal to t2n by 3 plus 1. Now before solving this recurrence relation, let's find out the value of a and b and fn by comparing this value with this generic recurrence relation. Okay, Tn is equal to t2n by 3 plus 1. In this recurrence relation, value of a is 1, value of b is 3 by 2, and value of fn is 1. Okay, value of a is 1, value of b is 3 by 2, and value of fn is equal to 1. Now let's calculate again n to the power log a at base b. In our case it would be n to the power log 3 by 2 at base log a at base b, 1 at the base 3 by 2, log 1 at base 3 by 2. Okay, now what is the value of log 1? 0. Okay, n to the power 0 and is nothing but 1. So in this case value of n to the power log 8 base b and fn both are 1. Okay, or we can say fn, if it is 1 we can write like this, it is n to the power 0. So we can say that fn is equal to n to the power log a at base b. So that means both quantity are equal. Now in this case, if both quantity are equal, that means second case is applicable. What is second case? Second case was fn is equal to theta n to the power log at base b. Then if that means both belongs to the same polynomial order. So in our case it is n to the power 0, n to the power 0, that means both are equal. That means we can directly apply the second case. If we apply the second case, then solution of this recurrence relation would be Tn is equal to theta n to the power log at base b. What is the value of n to the power log at base b? 1 into log n. The solution of this recurrence relation is nothing but log n. Okay. Now let's solve one more recurrence relation. Tn is equal to 3tn by 4 plus n log n. Now similarly, in this case we also find out value of a is 3, b 4 and fn is equal to n log n. Now let's calculate n to the power log a at base b. N to the power log a at base b. If we find out this value, it would be n to the power log 3 at base 4, and value of log 3 at base 4 is 0.75, so it is n to the power 0.75. Now next step is comparison of polynomial comparison of fn and n to the power log at base b. Now it is clearly visible that value of fn is greater than n to the power log a at base b, because it is n log n and it is n to the power 0.75. Now we have to compare this, whether these values n log n is definitely asymptotically greater than n to the power 0.75. Now but we have to check out in terms of polynomial of n. So here value of n is 1, n to the power 1, and here is n to the power 0.75. so we have to find out a value epsilon in such a manner that these two quantity becomes in the same order. So in that case value of epsilon would be 0.25. Okay. Now if you look at the third case, fn is equal to big omega n to the power log at base b plus epsilon for some constant epsilon greater than 0. Now if I put 0.5 here, so n to the power log n equal to n to the power 0.75 plus 0.25. This is nothing but our epsilon. So after putting the value of epsilon, both values become the same order. Same order means both belongs to the same polynomial power of n. That means in this case third case may be applied. Now before, whether we can apply third case or not, we have to check out one more condition, that is the regularity condition. And as per this condition, a fn by b must be less than equal to c fn for some constant c which is less than 1. Okay. Now for that purpose, from this discussion we have already find out the value of epsilon is 0.25. so we have write it here, epsilon is 0.25. Now we have to calculate a f n by b is less than equal to c f n. Now after putting the values in this, a, what is the value of a? 3. What is the value of fn? N log n. Now in place of n you have to write n by b. What is the value of b? 4. So it is n by 4 log n by 4 less than equal to c. What is the value of n? N log n. Now we have to check out whether this inequality holds or not. Now look at this. Now take an analogy. 3, it may be written like this, 3 by 4 n log n by 4. Now I can claim that this quantity is always less than 3 by 4 n log n for all values of n. because it is n by 4 and it is simply n, so this quantity is always greater than this quantity. Now so I can rewrite this like this: 3 by 4 n log n less than equal to c into n log n. Now if we compare these two things, this quantity should be always less than equal to this quantity, and if I write the value of c as 3 by 4, or in other words we can say that 3 by 4 n log n less than equal to c is nothing but 3 by 4 n log n. Okay, if write the value c 3 by 4 n log n, this quantity become equal because left hand side is right hand side. Now again look at the third case. As per the regularity condition, it says a f n by is less than equal to c f n for some constant c is less than 1. That means for any single constant or any constant which has the value less than 1, and if both quantity becomes equal, that means we have find out our c. So in our case it is 3 by 4. Okay, for the 3 by 4 this inequality holds, so in other words we can say value of c is 3 by 4. Okay, if the value of c is 3 by 4, so we have also find out the value of c. This is nothing but 3 by 4. Now we have already checked this and find out the value of epsilon. The value of epsilon was 0.25, and after doing the checking the regularity condition, a f n by is less than equal to c f n, we have also find out the value of c, which was 3 by 4. Now if both inequality holds, then we can write out the solution in single line, and the solution would be Tn is equal to theta fn. What is the value of fn? N log n. So this is our solution of this recursion relation. Tn is equal to 3Tn by 4 plus n log n, and this is the solution. Tn is equal to theta n log n. Thank you.